Have you ever thought about how a massive, complex oil refinery gets a checkup? I mean, you can't exactly ask it to cough. Today, we're going to pull back the curtain on a super critical maintenance procedure that's basically hiding in plain sight: chemical cleaning. You should really think of it as a doctor's visit for the very heart of our industrial world. A procedure that keeps everything, and I mean everything, flowing. All right, so here's how we're going to break it down. First, we'll diagnose the problem, what I'm calling industry's clogged arteries. Then we'll look at the seriously high-tech solution. After that, we'll peek inside the chemist's toolkit, walk through the super precise process, and finally, we'll get to the big payoff. Why do this in the first place? Okay, let's get right to the heart of it. Why is this industrial doctor's visit so incredibly necessary? What's the problem we're trying to solve here? Now, this might sound like the start of a weird joke, but stick with me. The answer is surprisingly simple, and it's really the key to understanding this whole thing. That's it. Simple, right? The massive, sprawling network of pipes, vessels, and heat exchangers inside an industrial plant, it's basically a circulatory system. When it's clean, everything runs like a dream. But when it's not, well, you've got a serious problem on your hands. And this is what that problem looks like. Over time, these systems get this kind of industrial arterial sclerosis. You get these nasty deposits, things like rust, scale, and this gross hydrocarbon sludge building up on the inside of all the equipment. And just like plaque in a real artery, this gunk chokes off the flow, it absolutely crushes efficiency, and worst case scenario, it can lead to a catastrophic failure. So, you've got clogged industrial arteries. What's the prescription? You can't just let it go, that's for sure. You need a really specialized, high-tech treatment. And here it is, chemical cleaning. Now, let's be clear. This is not about pouring some off-the-shelf drain cleaner down a pipe and hoping for the best. No way. This is a sophisticated, highly engineered process. It uses very specific chemical formulas designed to literally dissolve and flush out those harmful deposits, basically restoring the whole system from the inside out. Now, I know what you might be thinking. Why not just, scrape it out? And yeah, you can do that. That's called mechanical cleaning, and it's great for big physical blockages. But what about the stuff that's chemically bonded to the metal itself, or the crud that's stuck in all those tight, impossible-to-reach corners? That's where chemical cleaning is the hero. It's really the difference between using brute force and using precision medicine. So, to prescribe the right treatment, our industrial doctor needs a really well-stocked pharmacy. So let's go ahead and take a peek inside the chemist's toolkit. And just like with people, you don't use the same medicine for every single ailment. The treatment has to be specific to the problem. So for something like rust and mineral scale, you'd prescribe an acid-based cleaning. For greasy, oily sludge, you're going to use an alkaline solution. For those really heavy hydrocarbons, like bitumen, you need some seriously powerful solvents. And for more delicate equipment, you might use a gentler process called chelation. So, the takeaway here is crucial. This is never, ever a one-size-fits-all approach. Every single cleaning job starts with a super careful diagnosis of the gunk to create a tailored chemical prescription. It's all about finding the perfect key to unlock a very specific chemical problem. All right, so the diagnosis is done, the prescription is written, now it's time for the procedure itself. And this is where you really see the incredible level of precision that's involved. This whole thing is a meticulously planned operation, not some rush job. It all starts with analysis. Think of it like pre-op. Then, the right method is chosen. The system is completely isolated from the rest of the plant. Then, you get to the heart of the surgery, the controlled circulation of the chemical solution. That's followed by a thorough rinse and a protective step called passivation. And finally, you have post-op, inspection, and verification to make sure the job was a total success. And if you want to really appreciate the level of control we're talking about, just look at the temperature. These chemical reactions are hugely dependent on it. The cleaning solution is heated up and kept within a super specific range, usually somewhere between 40 and 90 degrees Celsius, to make sure it works perfectly without damaging any of the equipment. This is pure applied science in action. And of course, when you're dealing with chemicals this powerful, safety is everything. I mean, it is absolutely paramount. This is not a job for amateurs. The teams wear full protective gear. We're talking full-on chemical suits. They set up containment systems just in case of spills. They're constantly testing the air, and they have these really strict procedures for neutralizing and getting rid of the used chemicals. So, after all that incredible planning, all that precision, all that careful execution, what's the result? Why go through all the trouble? let's talk about the payoff and see what a healthy industrial facility looks like. The ultimate goal, to put it simply, is to restore the system to its optimal operating conditions. You're basically turning back the clock, getting the equipment to run just like it was brand new. And the operational benefits? They're immediate. Flow rates shoot up, performance gets a huge boost, and things like heat exchangers start working efficiently again. Plus, by getting rid of all those corrosive deposits, you're actually extending the life of these multi-million-dollar assets and preventing a lot of unexpected breakdowns. And you know what that means? It translates directly into major cost savings. A clean piece of equipment uses way less energy. Preventing a catastrophic failure saves a fortune in replacement costs. And maybe the biggest one of all, a planned chemical cleaning prevents a hugely expensive, unplanned shutdown. And finally, you've got the safety and quality benefits. Removing potentially flammable gunk makes future maintenance, like welding, so much safer. It gives inspectors a perfectly clean surface to do their job right. And remember that passivation step we talked about? That creates a protective layer that helps stop future corrosion before it can even start. So the next time you drive past a huge refinery or a power plant, just remember the invisible, high-stakes medical procedure that's probably happening inside its veins. This is one of those critical, hidden processes that literally keeps our entire industrial world flowing. It really makes you wonder, doesn't it? What other essential processes are out there, working perfectly, completely hidden in plain sight?